Hi students, let's look at this question here, which is quite interesting. It's on vectors. It was asked by one of my students. It was taken from one of the school's tutorial. This is not my question, okay? But this question is basically asking you to find the expression, basic result. This is not a basic result. Let's just dive into it and see how do we solve this. We are told that actually P and Q have this position vector. So what I'm going to write down now is basically just gonna write down OP is equals to A plus B, okay, and then OQ is given by 3A minus 2B. So this is okay. Relative to the origin A, O, given that OPQR is a parallelogram, express vector PQ and PR in terms of A and B. Okay, that's okay. So now what I'm gonna do is I'm just gonna draw a parallelogram as such. Okay, and then try my best to see how do we solve this problem here properly. Okay, here, so there you go. Now we have got OPQR. So this is O, P, Q, and R. Okay, so you're told that express vectors PQ in terms of PR in terms of A. Okay, so what I'm doing now here is because in order for me to visualize what's going on here, so that's why I'm drawing this. From this diagram, I know that the PQ will be given by OR. It may be useful later, I'm not sure, but I'm just going to draw this. Then after that, OP is given by RQ. Okay, so this vector here equals to this, and the opposite one equals to opposite one. So that's just vector that you learn in your secondary school. So that's all right. Let's look at how do we solve a PQ. So you're asked to solve for PQ. PQ is okay lah. So for PQ, what we're gonna get is actually just OQ minus OP. So this is all right. I think this question, this part should be quite doable. So this part here, minus of A plus B. So what we're gonna get from here is just 2A minus 3B. Okay, so this is my PQ. Rest for my PR will be equals to, what's my PR? P to R, right? P to R is given by OR minus OP. Do you see that now with the OR, I know that OR is PQ, so I could actually just use PQ in it. So R is PQ, OR is just OR is PQ, so this is PQ minus OP. So that's okay. So PQ would just be 2A minus 3B minus of OP, which is actually just OP is A plus B. So this is how I'll solve it. So from here, what we're going to do is actually just A minus 4B. All right. So there you go. I think that's the answer. So let me check. Yeah, there you go. Now, by evaluating two scalar products, you're asked to show that mod A squared equals to 2 mod B squared. So at a glance, this may look like very difficult, but if OPQR is a square now, so if you were to draw a square as such, so this is OPQR. Now, note that whatever properties that parallelogram has, the square has. So basically, whatever result you used previously could be applied to the square. Okay, just parallelogram is just a slanted square. So now we know that by evaluating two scalar products. So I'm just going to find two scalar products and try and solve this. Okay, now the best scalar product that I have is actually, I could know that actually OP is perpendicular to OR. So this is probably the best one, which is actually just OP dot with OR is equals to 0, since it's 90 degrees, right? That is one dot product that I could consider. The other dot product, this is 90 degrees. Okay, the other dot product, I could actually get whatever is being found, which is actually previously, which is PQ and PR. Where's PQ? PQ is just OR, so PR is a diagonal here. Okay, this dot product here I could use, but this 90 degrees here I could, this 45, sorry, let me do this. This one is here. Okay, so this 45 degrees here, I could use this dot product, but I think it will be a bit troublesome. I could also I'm not very keen in taking the dot product of PR dot PQ equals to mod PR mod PQ cosine 45. Not that keen because it's not 0. What I'm keen is the diagonal. I know that the diagonal of a square definitely is perpendicular to each other. So I know that PR, since it's perpendicular to OQ, so I could write this as PR dot with OQ. Then I'm just gonna hope for the best, because if I would take these two dot products, which is you dot them is 0, hopefully you could get the expression that they want you to find. If you can't, then I have no choice but to use the 45 degrees. But I'm gonna use the first one, or from 1. What we're gonna get is actually just OP dot OR equals to 0. So OP is given by A plus B. OR, which is given by, what's OR? OR is given by PQ, which is actually, OR is just PQ, 2A minus 3B equals to 0. So this will be 2A dot A minus 3A dot B plus 2B dot A plus 3B dot B. So this is the one. Basically, I'm just going to put mod A square minus, this is minus A dot B, so this is okay, minus 3 mod B square. So this is one equation that I get from 1. From 2, similarly, from 2, what I'm going to do is I'm just going to write down PR dot OQ. What's PR? PR dot OQ. Do I have OQ? Yes, I do. So PR dot OQ is equal to 0. So PR is given by A minus 4B dot OQ, which is actually given by OQ is 3 minus 2B, 3 minus 2B. So this is 3A minus 2B, and this is 0. So this is 3A dot A minus 2A dot B minus 12A dot B plus 8B dot B. Similarly, what I'm going to do is A dot A is mod A square, so this is mod A square minus 14A dot B, and this will be 8 mod B square. Okay, so from this part here, you could see that actually A log B is equals to 2 mod A square plus minus 3 mod B square. So I'm just going to sub 3 into 4 So substituting 3 into 4, I'll get 3 mod A square minus 14 2 mod square minus 3 mod B square plus 8 mod B square equals 0. So from here, I'm hoping that I'll get the answer which they asked me to do. So I'm just going to key in calculator quick. 14 times 3, 42 plus 3 is 45 mod A square. No, I'm wrong. 3 minus 14 times 2, which is actually minus 25 mod A square. 14 times 3 plus 8 plus 50 mod B square. Okay, so hence this is a mod A square equals to 2 mod B square shown. Okay, what else you find? Yes, shown. So just consider the two scalar product, which is the one with 90 degrees, because that will be the easiest to find. Okay, so if any question or comments, please do leave a text text me and ask. If not, please just keep on practicing. Okay, the questions is pretty, just keep your question coming in. I will just find time to help you solve them. Okay, see you in the next video.